Hello, I'm Puja Chawla, Assistant Professor of Physics, JMIT Tadur. Today we are discussing about the topic optical fiber. We will discuss each and every topic of this subject with detail. Optical fiber. Optical means light, fiber means thin hair-like structure. Whenever the transmission of light occurs through a thin hair-like structure, then it is named as optical fiber. Three main parts of the optical fiber are core, cladding and protective jacket. Core is the innermost cylindrical portion. Fiber, it's made up of fiber. Second is the cladding. Cladding provides a different refractive index so that the fiber is having higher refractive index than that of the cladding, because now the refractive index gradient would be there, and if the refractive index of the fiber is greater than that of the cladding, then the fiber would act as a denser medium and the cladding would act as a rarer medium. Now, when the beam suffers a reflection from the denser medium to a rarer medium, that means total internal reflection would take place if the angle of incidence is greater than that of the critical angle. That's why we have taken the combination of core and cladding with different refractive indices. The third portion or the external portion is the protective insulating jacket. Protective insulating jacket provides a protection against the moisture or the external damages. Now, working of optical fiber. Working, it's a theta A, one beam that is entering from air into the fiber core combination. When the light enters from the air, the angle of incidence is theta A, that is named as the acceptance angle. When the incident beam is incident at theta A angle, it will be incident at an angle phi within the core, and that angle of incidence is greater than the critical angle. Now, when the angle of incidence within the core is greater than the critical angle, it will suffer a total internal reflection. When the beam suffers a total internal reflection, it would be received at the receiving end without any distortion. Now, the beam is totally internally reflected and transmitted from transmitter up to the receiver with very less amount of distortion. The angle theta A is the angle which is accepted by the fiber core for the total internal reflection to occur. Now we will define the angle of acceptance. Angle of acceptance or the cone of acceptance is the acceptance cone for which the beam will suffer total internal reflection within the optical fiber. Types of optical fiber. Now we are discussing the major types of optical fiber. There are two main types. Number one is monomode optical fiber and number two is multimode. Mono word means single. If a single wavelength can be transmitted, then it is named as monomode optical fiber. And if multiple wavelengths can be transmitted, then it is named as multimode optical fiber. There are two main categories. Number one, step index. Number two, graded index. When I am saying step index and graded index, there is only a difference in the core refractive index and the cladding refractive index. We know cladding refractive index is lesser as compared to that of the core. And if I am saying this less quantity is in the form of a step, then it is named as step index optical fiber. And if this lesser quantity means fiber refractive index is greater than that of the cladding, and if there is a grading in the refractive index of core and cladding, then it is named as graded index optical fiber. This is the very first part, that is monomode optical fiber. I have earlier told that it's a single mode optical fiber, that means single wavelength can be transmitted. The diameter, that means the diameter of the core is very small, that only a single wavelength can enter. Here in this case the core diameter is approx 2 to 8 micrometer and the cladding diameter is approx 120 micrometer. Here the input signal is transmitted as such and the output signal is exactly the same as that of the input signal because only the single wavelength is being transmitted. Next category is multi-mode optical fiber. When I am saying multi-mode optical fiber, that means multiple wavelengths can be transmitted. Here multiple wavelengths can be transmitted because the diameter of the core is very much greater than that of the cladding. Here the diameter of the core is approx 50 micrometer and that of the cladding is approx 120 micrometer. Because the multiple wavelengths are passing, that means the input signal is distorted at the output end. Here we can observe the input signal is having less width and the output signal, the width of the signal is very much larger as compared to that of the input. The output will get distorted. Basic optical fiber line system. In this basic optical line system, we can say initially we have a transmitter signal. Transmitter means that converts the optical signal into a digital signal. Then that digital signal is transmitted, the digital signal would be converted into the optical signal. Optical signal is transmitted through the optical fiber and at the reception end, the optical fibers means optical signal is again converted into the digital signal. Now we are discussing about the applications of optical fiber. There are so many applications. Number one, medical application, surgery, defense application, radar signal transmission, optical fiber sensors, cars, door, communication application, telephone lines, consumer product applications. For example, we have the optical fiber decorative pieces. Thank you so much. If you like this video, don't forget to subscribe it on YouTube.